Research Methodology. Chapter 4. Tools used for data analytics. Part 1. Introduction to Statistical Techniques. Statistical techniques are methods used to collect, organize, analyze, interpret, and present data in a meaningful way. They help researchers convert raw data into useful information for decision-making. The word statistical comes from statistics, the science of working with numbers. Techniques means the specific methods or tools used to handle and process data. In research, raw data alone cannot give clear answers. Statistical techniques help summarize complex data, spot patterns and trends, and draw logical conclusions from numbers. They are widely used in business, economics, social science, education, and medicine. For example, if a researcher collects marks of 500 students, they use statistical techniques like averages and graphs to understand how the class performed as a whole. Types of statistical techniques. Descriptive statistical techniques describe and summarize data using measures like mean, median, mode, tables, and charts. Inferential statistical techniques draw conclusions about a population from sample data using tests like t-test, chi-square, and ANOVA. Measures of relationship analyze relationships between variables. Correlation shows the degree of association, and regression predicts one variable from another. Probability techniques assess uncertainty and risk by finding the likelihood of events occurring. Descriptive statistics. Descriptive statistics refers to techniques used to organize, summarize, and present data in a simple and meaningful way without making predictions or generalizations. The word descriptive means to describe or explain. So descriptive statistics simply describes the basic features of a dataset in a clear and understandable form. The main tools include measures of central tendency, mean, median, mode, measures of dispersion, range, standard deviation, and data presentation methods like tables, charts, and graphs. Together, they make large and complex data easy to understand. For example, a teacher who wants to understand student test scores uses descriptive statistics to find the average score and draw a bar chart showing overall class performance. Measures of central tendency. A measure of central tendency is a single value that tells us where the middle or center of a dataset lies. It represents the typical value of a group of data. The word central means middle, and tendency means a general direction or pattern. Together, it means finding the value around which all the data tends to gather. There are three main measures: mean, the average, median, the middle value when arranged in order, and mode, the most frequently occurring value. Each represents the data differently depending on the type and distribution of values. For example, if 5 students scored 50, 60, 70, 80, and 90, the mean is 70. This represents the typical or central performance of the whole group. Mean, merits. Rigidly defined, its value is always fixed and definite, so there is never any confusion about the result. Easy to calculate, simple addition and division makes it quick to find and easy for anyone to understand. Based on all observations, it uses every value in the dataset, making it a good and reliable representative of the whole group. Easy to compare, it can be used to compare 2 or more datasets or groups in a straightforward manner. Capable of further algebraic treatment, the total of all values or the combined mean of different groups can be found using it. Least affected by sampling, small changes in the sample do not significantly change the mean, keeping it stable. Mean, demerits. Affected by extreme values, very high or very low values distort the mean and give a misleading result. Cannot be found by inspection, cannot be guessed by looking at data, must always be calculated. Fails if one observation is missing, if even one value is lost, arithmetic mean cannot be found. Not usable with open-end classes, mean cannot be determined when data has open-ended class intervals. Median, merits. Rigidly defined, clearly defined, and always gives a fixed, consistent value. Easy to calculate, simple to find once the data values are arranged in the correct order. Not affected by extreme values, very high or very low values do not change the median, making it more reliable. Can be found by inspection. In small datasets, the median can be located just by looking at the arranged values. Useful for qualitative studies, it can be used even for data that cannot be measured in numbers, like rankings or opinions. Can be located graphically, the median can be found using a graph, especially with ogive or cumulative frequency curves. Median demerits. Arranging data is tedious. All values must be arranged in order of size first, which is very time-consuming for large datasets. Cannot give total value. Multiplying median by the number of items does not give the total of all values, unlike the mean. Not suitable for algebraic treatment. The median cannot be used in advanced mathematical calculations or combined with other statistical measures. More affected by sampling fluctuations. The median can change more than the mean when different samples are drawn from the same population. Mode, merits. Usually an actual value. Mode is normally a value that actually exists in the data, not a calculated or assumed number. Easy to locate by inspection. In discrete series, mode can be found simply by spotting which value appears most often. Not affected by extreme values. Very high or very low values in the data have no effect on the mode at all. Can be found without extreme values. Mode can be calculated even when the extreme values of the dataset are unknown. Easy to understand. People naturally use mode in everyday life, making it the most relatable measure of central tendency. Mode, demerits. Not based on all observations, mode only looks at the most frequent value and ignores all other values in the dataset. Not suitable for mathematical treatment. Mode cannot be used in advanced algebraic calculations or statistical formulas. May have more than one mode. Sometimes a series has two or more modes, which makes the data confusing to interpret. Does not give total value. Multiplying mode by the number of items does not equal the total of all values in the data. Not reliable in small groups. If only a few items repeat in a large group of varied values, mode does not truly represent the group. Watch part 2 next. Measures of dispersion and inferential statistics. Like and subscribe to Ria's Notes. Ria's Notes.